feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe can take this. I can see it clearly now, nothing gonna bring me down. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. I got my head held high, I'm on my way, and I'm following the signs to my happy place. I'm walking in the light of a brand new day, and I'm right where I belong in my happy place. And I'm right where I belong in my happy place. And I'm right where I belong in my happy place.
Welcome to the National University of Singapore Yonglulin School of Medicine Healthy Longevity webinar. It is absolutely great having you with us today. Nika Pintar is our guest. She will explore the gut-brain axis. Do you know that we carry 1.5 kilograms of microbes with us? And I can tell that they should be our friends. I'm sure that this topic will trigger lots of questions. Please use the Q&A function to share them with us. We start as always with a short presentation, and this time by Si-Meng Lim, our research associate at the NUHS Center for Healthy Longevity. And he will talk also a little bit about the brain, about dual tasking.
Good evening, everyone. As mentioned, I'm Ji-Meng, a research associate from the Center for Healthy Longevity. Today, I would like to present a brief talk titled Dual Task Cause and Aging. During the presentation, I will address the definition, published journal articles, conclusions and limitations, as well as future research. Dual task cause typically refers to the performance changes when an individual is required to perform 2 tasks simultaneously compared to when each task is performed in isolation. This concept is often studied in cognitive psychology and neuroscience to understand the limitations of human attention and multitasking abilities. When individuals engage in dual task situation, their performance on one or both tasks may suffer due to the limited cognitive resources available. The dual task cause is the additional effort or decline in performance that occurs when dividing attention between 2 tasks. Researchers may use various measures to assess dual task cause, including reaction time, accuracy, or other performance metrics specific to the task being studied. Now, here comes our question. Is aging contribute to dual task cause increment? The answer is yes, and this finding is supported by various previous studies. For instance, a meta-analysis in 2003 showing that the effects of dual task processing on latency were found to be additive, with a larger cost in older adults than in younger adults, independent of task complexity. In a nutshell, numerous studies support the idea that as individuals age, there is an increase in dual task costs, meaning that performing 2 tasks simultaneously becomes more challenging. The next question, is there a preventive or improvement method available to mitigate the dual task costs, particularly in enhancing cognitive function? The answer is also yes. There are studies that show that dual task performance can be improved by practice. A range of studies have explored the impact of physical exercise and cognitive training, and the combination of both on dual task costs. Berer and the team demonstrated cognitive training specifically improved dual task costs. In addition, the team also found that combining cognitive and physical training can help your brain handle multiple tasks more efficiently. Global systematic reviews indicates exercises entail clear benefits during dual task performance. According to Zanato's study, exercise is effective to improve single or dual task performance in elderly subjects with disease condition. So Eggerberger in 2015 discovered that a training program involving both cognitive and movement exercises, like playing virtual reality video games and walking on a treadmill, while also engaging in verbal memory tasks, can improve your ability to walk while multitasking. Secondly, as suggested by Jardim in 2021, a mixed physical exercise program potentially incorporating virtual reality has been shown to enhance both cognitive and physical abilities in healthy older adults, potentially slowing down age-related cognitive decline. This study collectively suggests that physical exercise, particularly when combined with cognitive training, can improve dual task costs in older adults. In conclusion, the dual task cost increases with aging. Secondly, consistent practice proves beneficial in preserving or even enhancing the dual task cost among the elderly. However, there are few limitations, including challenges of application in real-life scenarios. Most people will not dedicate their time and money to practice specific cognitive tasks just to excel in a particular cognitive domain. Also, there is a lack of consensus in previous research. With that, we are excited to announce our preparation for an upcoming research trial focusing on the study of motor cognitive training intervention. Motor cognitive training is a type of exercise or intervention that combines both physical and cognitive elements. This training approach aims to enhance not only physical abilities, but also cognitive functions such as memory, attention, and executive functions. We aim to initiate the research this year. For further details and updates, please visit the Centre for Healthy Longevity websites. Thank you.
Thank you so much, Simeng. I think you really nicely showed that we can modify our brain, how good our cognition is. So the question now is, should we only do that with physical activity, or what is the role of the microbiome? So it is my absolute great pleasure to introduce you to Nika Pintar. She is the co-founder and chief of Ani Biome, a longevity biotech startup focused on mental and emotional health and their connection to aging-related processes, so the gut microbiome. She will discuss their approach and to the longevity ecosystem, and maybe also how to disrupt the longevity ecosystem a little bit, and maybe also with machine learning. Over to you, Nika. It's an absolute pleasure having you.
Hi, Andrea. It's really, really lovely to be here. So I'm connecting from Davos, from World Economic Forum, where longevity is being discussed on so many sides. And it's so great to see that longevity is becoming such a hot topic and a mainstream topic, because everyone should be focusing on it. Without further ado, I will share my slides now and dive deeper into what we do at Ani Biome. So as Andrea already mentioned, I'm the co-founder and chief at Ani Biome. It is a great honor to be here today. Thank you for having me. And I will dive a little bit deeper into the gut-brain axis and how does this communication channel actually influence the aging processes and longevity in total. So first to start, we need to talk about why is that even important? Well, more than 40% of people worldwide suffer from gut-brain interaction disorders, and that is what we know. So perhaps the number is even higher. However, what is really important to take into account that up until last year, they were called functional gastrointestinal disorder. So this is really an emerging field of science, this understanding that this is not just about the gut, but that there is a communication channel, a pathway that is continuously communicating and sending signals one way and the other, and that one influences the other. So it's always the question, which one came first, right? Well, what is the chicken? What is the egg? And so on. However, when we look at the gut-brain interaction disorders, the most prevalent one is IBS. And at this moment in time, we are not able to effectively address it. And what we've seen also, and what science knows, is that in all of these gut-brain interaction disorders, what is disrupted is the gut barrier integrity. Now, when we look at the pathophysiology of the gut-brain interaction disorders, we need to understand, again, that it's not just about the gut, but also about those psychosocial aspect, the neurologic aspect, the gastrointestinal aspect in a sense that people are feeling pain, altered motility of their stool, and 2/3 of people suffering from gut-brain interaction disorders go on to develop anxiety and depression, which leads to really severe healthcare costs, but not just that, but also severe impact on their life quality. I personally experienced it on my own skin. I suffered from gut dysbiosis. I went for a very simple medical procedure. I was prescribed painkillers, and basically they ruined my stomach. I ended up with 3 stomach ulcers, and that was a process that just went on, and it took me more than 2 years to get my life back on track. And what was the worst part was that while I was going through the process, at a certain point in time, I actually accepted that I have a lower quality of life. I felt it was suddenly normal that I wouldn't go out when it was raining or it was windy because I would start suffering from migraines. I couldn't go running because I would get panic attacks. And those are the things that people suffering from gut-brain interaction disorders experience every day of their life. And that is something significantly impacting their cognitive function, ability to regulate their emotions. More than 94% of people suffering from IBS have issues with mood regulation. So it's also a problem of the society, because a person is not an individual. They're surrounded with their families, with their friends. And unfortunately, in these situations, we don't have a solution and we don't have a structure to support such individuals. Now, when we look further into the problem of mental health, and as I mentioned, anxiety and depression, which are connected to our gut, the annual cost of anxiety and depression on the global economy is projected to be $1 trillion US. That is only 1 year. So I'm not even talking about the other effects, as I just mentioned, on the family, on the friends, on the complete social aspect, on one's productivity, on one's level of energy, creativity, etc. So at Ani Biome, what we are building is a digital platform to be able to longitudinally assess the state of one's mental health and emotional capacity as a digital biomarker to truly understand on a longitudinal way and predict and assess the state of one's mental health in order to provide personalized interventions, because everyone's gut-brain communication channel is different. Our gut microbiome is as unique as a fingerprint. And what's really important to take into account is also that it adapts and shifts throughout our lifetimes. And it's really severely affected by various lifestyle impacts, jet lag, and different physical activities, etc. So it all shapes our gut microbiome. When we talk about the diagnostic part of our platform, because we provide both diagnostics and therapeutics, we developed a digital platform for a non-invasive longitudinal assessment. What's really important is that this assessment is on a daily level, so we are able to understand how a person's behaviors, how their mood, how their thought patterns, etc., are changing on a daily level, and to be able to monitor their mental and emotional states. Now, the scan itself is very simple. What it is, it comprises of a biometric scan with people are starting first with a daily scan of their tongue, as you can see on the photo. Now I'm a tongue model all of a sudden. And this biometric scan, as we know, the tongue is the beginning of our digestive system. There are multiple factors related to our digestive system that we can see from the tongue, but not just the digestive system, but the state of other organs as well. So we are integrating knowledge from various medicines into our machine learning architecture behind. So for example, it is well known in the traditional Chinese medicine practitioners are checking the tongue in order to assess the state of a person's health. Then, for example, in Western medicine, it's also known that, for example, if a person has IBD, there are changes happening on the oral level, even before we can see it on the level of the gut. So that's what we are focused on, to be able to really longitudinally provide a solution to monitor the changes, observe them through a longer period of time, to understand what is a person's baseline and how it is changing based on various lifestyle factors. We integrate data from wearables. So for example, we recently partnered with Oura Ring, so we can understand those lifestyle factors, how a person is sleeping, what is their cardiovascular activity, and integrating that with our machine learning models for prediction of the impact of small molecules on different metabolic pathways in order to provide tailored interventions. Now, a great aspect of this is also assessing the subjective experience. So we are asking our clients to provide their feedback on how they are feeling. And then we are matching this aspect of the subjective experience together with the objective measurements through the wearable data and also through the scan of the tongue. When I'm talking about the intervention, I'm talking about a wide spectrum of highly bioavailable bioactive compounds that are derived through our proprietary fermentation methodology. They come in the liquid format in a simple pouch that all you need to do is snap in a glass of water, and it's super easy and convenient to take with you wherever you go. And what's really important is that they're packed with various micronutrients. So I'm talking different polyphenols, organic acids, biopeptides, amino acids. And what we are looking at through our machine learning models is their impact on different metabolic pathways. So we designed a system, graph neural networks, in order to understand this impact, and not just one molecule, but the synergistic effect of the multiple, of the variety of the bioactive compounds that are found in our H-biotics. Now, what is really exciting, I would like to share also a little bit behind and what's also happening in the world. So there was a recent paper that was published on the theory that it was actually the fermentation technology that drove the human brain expansion because of the bioavailability of the micronutrients. So when we are talking about fermentation, we must address the topic of bioavailability and bioaccessibility, because what fermentation basically is, it's a process of pre-digesting food. That makes it much easier for our bodies to absorb all the valuable micronutrients and to be able to turn them into a source of energy and to establish a balance within our metabolism. So just to summarize, we start with the biometric scans to gather longitudinal data. It's on a daily level. This enables our personalization machine learning models that are based on the predicting the effect of various small molecules and how this adapts to each unique individual that is joining our program. And they receive on a monthly level personalized blends of micronutrients according to their needs. One more time, this is all based on our fermentation methodology in order to increase the bioavailability and to provide a wide range of micronutrients. One thing that I must mention are also short-chain fatty acids. Why? Because I will dive a little bit deeper in a little bit, but basically we preclinically and clinically validated already our H-biotics in a sense that they are modulating short-chain fatty acid production, and short-chain fatty acids are fundamental for hormonal health, for the cognitive function, for our mental health overall. And they are an energy source for epithelial cells in the gut. So what's really important, I touched upon it earlier, is that when we look at the gut-brain interaction disorders, what is evident is this, that there is a disruption in the gut barrier integrity. And our gut barrier has a dual function. So it needs to choose what goes in and it needs to choose what goes out. It seems very simple, but once it is disrupted, it can lead to systemic level of inflammation over a longer period of time. That's why it's really important to keep it intact. Also, what's very important about short-chain fatty acids is that they can directly affect the brain by passing through the blood-brain barrier. This is something that we will be now further investigating through our preclinical trials to really see what is the effect. one also additional interesting thing is that they also impact the regulation of appetite and blood glucose levels, which is extremely important for longevity. And they also, when we look at our body as a bioreactor, they influence the production of calories within our body. So basically, we are able to modulate our caloric intake by enabling our body to be the bioreactor it is supposed to be and to produce the calories within, and also regulate the appetite and blood glucose levels better. So we are not in that loop of continuously needing to feed ourselves further. And when I'm talking about short-chain fatty acids in connection to our biological intervention, so besides the clinical trial, which just finished together with Freie and Wageningen University, where we were looking at gut microbiome diversity and various inflammatory panel from the blood, we also conducted preclinical trial using the gut-on-a-chip methodology in a simulated leaky gut model. And what we've seen that already one dose of H-biotics improves short-chain fatty acid production up to 122%. That is only a single dose. So for the gut-on-a-chip experiment, we utilized feces of healthy donors. Now the next steps will also be to utilize feces from specific sick donors and so on to see how that modulates the effect. What we've also seen was the effect on restoring the gut barrier integrity and increasing anti-inflammatory cytokine production. However, what I would like to emphasize further is that our H-biotics are also already on the market, and we have real people utilizing our products. And we are also using their inputs. So what they are providing us with in terms of anecdotal evidence for the continuous feedback loop. And also when we are deciding what will be the next fields of scientific evidence that we will be looking at. So for example, 90% of people who have been with us for more than 3 months have experienced positive impact on reducing bloating and reducing acid reflux. 82% of people have seen increase in their energy levels. And we've also witnessed several other anecdotal evidence, such as impact on appetite regulation, impact on the ability to focus and to modulate the cognitive function. So for example, some people said they no longer needed their morning coffee and they would just be ready to start their day after their dose of H-biotics. And here I just made a small overview of just several projects that are currently ongoing in terms of Ani Biome and our scientific strategy. As I mentioned, we just finished a randomized control trial with Freie University and Wageningen University in research. So it was a placebo-controlled double-blind study. We are now in the process of bioinformatics. The preliminary results are very promising, and I can't wait to be able to share more. We are also assessing the impact of H-biotics on mitochondrial function and oxidative stress. And my personal favorite is the pilot project on validating our IBS machine learning model. So we developed a machine learning model for predicting whether a person has IBS, and we are now validating it through a study with a study population of 60 participants with 2 arms, and also including healthy participants in order to understand the differences. So to wrap up, we are utilizing all of these different data points. So the data points from the clinical trials, the data from the preclinical studies that we are conducting, also the data that we are collecting from our clients in order to further enhance the machine learning architecture that is enabling our personalization. Because as Andrea mentioned, we are in the field of disrupting. So we are disrupting in a sense that we are not looking, our approach is looking beyond the state of disease and also understanding that each and every disease has its own trajectory. And two individuals having the same diagnosis will have different paths. So their state of disease will have a different trajectory. For some people, it might move quicker. For someone, it might move slower, and so on. And ultimately, really focusing on the state of one's mental health. If I may share a bit of a personal story, my mother lived with leukemia for 16 years. That was, let's say, statistically, she lived the longest she possibly could, given her state. But I've witnessed firsthand what it means when a person goes through that and how the state of disease reshapes their state of mental health. Now we know this is, again, an emerging field. The last year or two, there are numerous studies coming out showing specifically that leukemia is connected to gut microbiome and especially short-chain fatty acid production. However, this impact on mental health was such a disruptor to our family life. And ultimately, that when we are talking about the longevity economy and the longevity society, what we are talking about is us as people learning more about our purpose, learning more about our interactions, and how through those interactions we can reshape the system in which we live. So how can we ultimately reach the maximum of the human capacity in order for us as population to go further? And that is the driving force between Ani Biome. We believe that this solution lies in the gut-brain axis, again, as a communication channel. And when we look at it, that everything that we get into interaction with, whether it be food, exercise, or the sun, fresh air, and so on, they're all inputs, they're all information. So when we are addressing the state of disease, we are looking on the biological processes, what are those interactions doing to our metabolic pathways, and how through these interactions we are shaping the subjective experience, mental health, emotional state, and how in turn those emotional states are driving the aging processes or potentially reversing them. And that is what we are focused on. It is a very exciting field of science to be in. There's still a lot to be explored. And we are just setting up. So this year, we are targeting to start 80 different clinical trials. And as I mentioned, H-Biotics already had clinical intervention trials on humans. So we will be conducting studies on humans, which is I believe one of the most significant things we can do to advance the field of longevity science. And we are continuously looking and expanding with further scientific partners. So if there is anyone who is looking to start some gut-brain axis studies and are looking for partners, do feel free to reach out to me, or even B2B collaborations in order to reach a wider audience and understand these underlying mechanisms better. So that's it in brief. Ultimately, it's not just about the person, our gut microbiome, our gut-brain axis. It's all about the interaction. It's all about the diversity. It's all about building an ecosystem. And our channel is the gut-brain axis as a communication channel that truly shapes our mental health. And we believe we can target it through the biological interventions, but also through the diagnostic platform that we are building to create Ani as a digital platform to enable longevity. Thank you.
Thank you so much, Nika. I already love the interaction with you. And I really love the interaction in our ecosystem, the longevity ecosystem, which you are absolutely disrupting. And somebody in this room was also disrupting it, where we are so glad that you are dialing in live from the World Economic Forum. So thank you so much. You have a wonderful product. What I really love is that you're doing studies, and while doing studies, learning, also taking into account the consumer feedback, and therewith, I think also designing the studies even better. So I think that's a clear example for the field, how the ecosystem should shape, I would say, the evidence within the longevity field. May I ask you, I'm a clinician, I'm an internal medicine specialist. How would I diagnose a disruption of the gut-brain interaction? How is it being defined and how could it be diagnosed? How could I know if my patients have it or if I have it?
So there's always, as I mentioned, it's both on the level of the gut, but it's also on the level of the brain. So for example, when we are looking at IBS, the statistics show us that from the moment when a person actually experiences the first symptoms, it usually takes them more than a year to actually get to visit a physician, more than a year. That is a huge problem because for a year, nothing is happening. They're not aware that it's turning into a more and more significant problem. And then when they do enter the system, in order to be diagnosed with IBS, it's not like you come and you have a test for IBS, but actually you first must be tested for everything else.
Yeah.
And then it's, oh, well, you don't have anything else. It's IBS in the end. So again, that is why we developed this machine learning model for IBS prediction. And that's why we are now validating it through a pilot study, because we believe, again, this is a space that definitely requires better methods in order to be able to understand the pathophysiology much quicker and to be able to identify the problem in the first place. And I've, having spoken with a lot of people who went through such problems, the problems even started manifesting first on the level of mental health. So people started feeling more sluggish, they started feeling lethargic, then they started experiencing panic attacks, and they would never connect it to the gut. They would just think, you know, mental health is such a wide issue. Everyone nowadays is experiencing, you know, low mood, not feeling so well, and so on. Everyone is distracted. But it's not supposed to be that way. That's why I mentioned we are going beyond the state of disease and actually understanding what is our full capacity as human beings. And that is why we need better methods to understand it. I don't think the system at this moment in time is really perfect, and we need better diagnostic tools in this space, definitely.
Yeah, so that's interesting because this is what I normally do in clinical practice. Others do in clinical practice. You exclude lots of things and then you say, okay, it's IBS, because I think we do not understand it too well. We understand it a little bit, but not too well.
But even when you say IBS, what is IBS? Because it's an umbrella term. There are so many different types of IBS. For someone, it may be going to the toilet too often. For someone, it may be going to the toilet too little. For someone, it's SIBO. And people just don't know. People don't even understand that every single thing they eat and drink interacts with this, and those are all signals and inputs we are providing our body with. That's why, as I mentioned, we are looking at our body as a bioreactor. So our bioreactor already knows what it needs to do, right? So the microbes were here long before us. They have certain functions. They're producing their own metabolites and so on. So just like we wouldn't put gas in a diesel car, but we are ready to put in a lot of things that were not in the human diet for the last century or even before that. And we have this misconception that the food we are eating today is the same food that previous generations were eating. But even when we look at vegetables and fruits, we became very good at engineering the best looking tomato or a very orange carrot just for it to be more appealing. But that's not how food used to look like. That's not what it used to taste like. And we can see that this food industry has been transformed in order to provide the best sensory experience. So we are looking, the driving force is the taste. We want the sweetness, we want this explosion of taste, and we completely forgot about the functionality. And we are putting functionality first. And when I'm talking about micronutrients, what I really like to point out is that we consider them supplements, but they are not actually supplementation. They are essentials. So that's something our body cannot function properly without. They are essential. So we need to provide our bodies with the right micronutrients, but again, taking into account what is the right micronutrient for which person at what moment in time. And that is why personalization and AI is enabling us to dive much deeper into this topic nowadays.
I love the precision medicine approach, which is a little bit different, of course, from the personalized medicine approach. But before coming towards really giving you the right supplements, whatever right is for that person in this time, let's go one step back to the microbiome. You said you have a fingerprint and you are observing it over time, and at least you do it with the tongue. But do you also observe the microbiome, the microbiome over time? It can be oral or out of fetus, etc. So how do you know that the fingerprint you see is belonging to that individual? Because we know that lots of microbes, there's a huge diversity and everybody is different as our fingerprint. So how do you actually know this is mine and this is yours and this is optimal for me or for you?
Well, there is still no definition what is a healthy microbiome. So each microbiome, again, is unique. Now, when we look at our methodology, so we focus on non-invasively assessing the state of one's mental health, and then through machine learning models, correlating it to the metabolic pathways and the different inputs that we are providing it with. Now, when it comes to stool sequencing and blood parameters and so on, we do that in clinical settings. So, for example, we use 16S analysis in our clinical trial, or O-link and so on, to look at multiple biomarkers, but we do not provide it for at-home assessments. We did have that previously. However, there is also an educational moment to it. So, for example, when we look at a stool sample, the current standard when we have at-home test kits is that someone does a stool sample once and then they do it, for example, after 6 months. But basically, our stool is changing on a daily level as well. So it depends on what you ate yesterday, what is it that your microbes needed to digest, even which methodology is being used to analyze the sample, or even which part of the sample is being analyzed. So if we had two samples from the same material, we would not get the same result. Yep. Plus, people have, when people are doing, for example, at-home blood test kits, you're always instructed never to touch the paper where the drop is supposed to go. Now, I've seen so many people being like, oh, there's this drop here. I'm just going to slightly touch it to get a little bit more on that paper. That is not supposed to happen. So immediately the sample is contaminated, etc. That's why we decided to utilize this in a more standardized, more controlled manner, where someone is instructing the individuals how to properly take the sample for it to be valid. However, we use the data for our machine learning models behind, so we can correlate it. But then that the end consumer doesn't actually have to go through all the hassle.
Yeah. Okay. Yeah, there's absolutely an issue with sampling, absolutely, and the variation. But at least you get a fingerprint where the inter-individual variation is much higher compared to the intra. But I think that's another talk and discussion point. I really love your approach, which is very scientific, and I saw lots of nice universities, also the Free University in Amsterdam in your slide, where you're going to validate what you do. However, you already have lots of customers who are now taking your supplements, etc. Can you tell me a little bit more about the moment when you said, okay, no, for me, it's enough evidence. I am going now to sell the supplement, my product, and I'm not going to wait until I have the definite evidence.
Andrea, so we are a science-first company. So in terms of the science, there will never be a moment, never, when it's like, okay, now we are at the ultimate level, we stop all R&D, let's just do sales. Because our body is such a complex organism with so many different interactions. So what we are looking at is the interplay of these different biological processes and how they relate to aging and how they relate to the gut-brain axis. So it's all from the angle of the gut-brain axis. However, it's really science first. As I mentioned, the target for this year is to enter 80 clinical trials, for example, on time-restricted feeding, especially in relation to the short-chain fatty acid production, and how we could potentially be able to even prolong the fasting period, but without the person feeling that they are fasting or feeling the appetite dysregulation and so on. And this is a very specific field. That's just one part. Then, for example, there's another study on gut-brain axis and the impact of stress that is starting in Q3 this year. That is it's going to be a 4-year project. It will include both in vitro and in vivo part of the studies and so on. And again, it doesn't end there, but not just the science itself, but also the machine learning models and the data and the predictions and how those two correlate. It's a never-ending process.
Yeah, I agree with you that the body is very complex. I think it's always the question, when are you ready for the consumers? How much do you blend, etc.? How much maybe additive value do you have with different supplements, or maybe they are intuitively not working together and diminishing the working process. But I think it's an absolute debate in our field, and also where I think the supplements in the wellness sector start or end, and where the medical field starts and ends. Before,
yeah, I would like to just add here is that H-biotics are really advancing the field of food as medicine. As I mentioned, they are derived from a fermentation process. Again, we have the question of bioavailability. So how much of what we are taking of the micronutrients we are able to absorb. So then being pre-digested, we are outsourcing the digestion process and actually mimicking the process, the digestive process of ruminants, in order to really get the optimal and the most bioavailable micronutrients from different herbs, plants, and fungal materials that we are utilizing through the fermentation. Now, that's one mechanism of action, is providing the body with the micronutrients from the liquid. But the second mechanism of action is modulating the work of the bacteria themselves, not just the bacteria, but the complete ecosystem and what it is producing. Here again, going back to the short chain fatty acids. So already a single dose has shown that it can improve the short-chain fatty acid production up to 122%. And again, short-chain fatty acid production, short-chain fatty acids are, again, a novel field in a sense of understanding all the different processes they're regulating, from our glucose levels, from cognitive function, ability to make decisions, ability to regulate our emotions, so many things.
Yeah, no, there is lots of observational data already. And no, I love, once again, I think sometimes you also really have good discussions here, but I really love your approach and your investment to do the randomized control trials, observational studies, even in vitro models of the gut microbiome, and exposing it to test it. My last question before going to Sabrina Adam and answering all the questions from the audience, there are lots already, is how did you come to the idea to just make photos of your tongue? I'm coming a little bit out of the traditional Chinese medicine field, so I always looked at the tongue, and it's absolutely an valuable organ, which is absolutely mislooked. But what was the moment that you say, okay, let's make a photo of my tongue?
I must think when it was the exact aha moment. It just came through the previous experience and knowledge. Bruno, my co-founder, has plenty of experience in various longevity, well-being, medicine practices, and so on. And there was always this observation that in traditional medicines, there were different ways to diagnose or observe one's state of health. And we were looking at what can be easy to scale, what is something that everyone can integrate into their routine. And as you already mentioned, doing stool tests, doing blood tests, it's not something that you really want to do on a daily level. You know, it's no one really likes the experience of getting a stool sample. You know, it's just not convenient at all. And we were thinking, okay, what can we do? But it's also about what will give us the maximum inputs, and understanding that the tongue has been a tool from which we were looking at different aspects of our organism, not just traditional Chinese medicine, but also Ayurvedic medicine, and Western medicine recognizes it as well. So it was about this aspect that there is already a lot of existing knowledge. And as you said yourself, it's an underutilized tool to be able to measure and evaluate one's health.
Yeah, thank you so much. Sabrina, I see lots of questions. Please kick in.
Thank you so much for sharing on the gut microbiome and how it relates to the psychosociological aspect of one's well-being. We have a lot of questions today. I will start off with an interesting one. Someone asked, how can research on the gut-brain axis be effectively translated into public health initiatives? And what challenges could you possibly exist in disseminating this knowledge with a diverse population such as our nation here in Singapore?
So in terms of the gut-brain axis and the existing knowledge that we have and the existing studies, it's really an emerging field, and it's something that requires further investigation. But that's why I already mentioned it's not just about looking at the gut-brain axis, but different biological processes related to it. What's really important is to conduct more human studies and to understand, especially in the sense of mental health, and how through mental health we can correlate it back to the gut. We need AI for that. So basically, up until now, we didn't have the let's say in the recent years, we actually started having the technology to be able to understand those correlations. However, there is still a lot in this field to be discovered. Now, in terms of the variety of the population, well, we need to understand each individual at the end of the day. That's why let's say the pillar of the Ani Biome approach is personalization. So it's not just we need diverse populations, but again, going back, it's about the biological processes behind. So really understanding it on the level of the biological processes.
Interesting, thank you. The next question asked, sorry, excuse me. Which bacteria are considered beneficial for the aging gut, and what sort of diet or specific food or supplements maybe would you advise for us to incorporate into the diet?
So there is still no definition of what is exactly a healthy microbiome. We cannot say we need exactly more of this species because, again, it's an ecosystem and there are many correlations. And again, it depends on your inputs. It depends on your diet, how you're living, what is your lifestyle like, how you're sleeping. So there are various inputs actually modulating your microbial ecosystem. Then we also have the viruses and so on. So it's not just about the bacteria themselves. What we do know, or what has been shown in the recent studies, is that a more diverse gut microbiome is connected to less inflammation and is connected to healthier longevity. So that's something that we should be looking at. So the microbiome diversity. For example, there was a study done at Stanford approximately 3 or 4 years ago, and it was a study that for the first time was looking at the immunomodulatory effect of fiber and fermented foods. And what it has shown was that daily intake of fermented nutrients actually promotes gut microbiome diversity and decreases inflammatory panels, inflammatory markers from the blood as measured by O-link. So that's why I was talking so much about fermentation and the bioavailability of the micronutrients. What it does, the fermentation process is a pre-digestion process, so our body can absorb it better. Even when we look at our anatomy, in comparison to other primates, we have a smaller large intestine. So the function of our small intestine is to absorb all of these micronutrients. And if we provide them in a more bioavailable format, if it's easier for our body to digest, then it influences other processes in the body.
Yeah, so it's definitely only one aspect of healthy aging that we should be paying attention to. So the next question is asking, at what age is it advisable for us to start replacing or supplementing our gut microbiota?
So in terms of gut microbiome field, so I will come back now to this study that was done at Stanford. So basically for the last decade, we have been told you need to eat more fiber because fiber is the thing that is lacking that will influence our gut microbiome positively. Now, what is really important is that this study that was conducted in Stanford was the first study of its kind to show that fermented foods actually modulate gut microbiome diversity better, and that even they had 2 fiber groups. One fiber group even had increased inflammatory markers after consuming fiber. And basically, when you eat, for example, more food that is supposed to provide you with fiber, your body needs to digest it more. So the energy goes into the digestive system to extract what it needs to extract from it. That's why in terms of fermentation, coming back to it, the pre-digestion is so important to outsource that part of the process outside of your body, and then your body can extract what it needs, can get what it needs much quicker and in a more efficient manner. Again, through the production of short-chain fatty acids, we are also producing calories. So hypothetically, we could reduce the caloric intake that is from food through optimizing the bioreactor that we already have inside our bodies. What is really important is to look at it from the perspective, what is the right micronutrient intake for me? At what time? What period of my life? Am I going through a more stressful period? Am I sleeping well? And so on. In which climate am I? Am I going through jet lag? For example, there are some new studies showing that when we experience jet lag, our microbiome is shifting so that it is changing, and that it takes around 2 weeks for it to establish again, in a sense. So those are, again, emerging studies. Those are all aspects that are influencing our microbiome. That's why what is really important is looking at the data in a longitudinal manner to establish patterns and to understand, again, the outcome, which we measure through the state of one's mental health and emotions. Ultimately, the goal is that you feel better. And when I say better, I mean have more energy, be able to be more present, to have better cognitive function. And that is the outcome that we are looking at and that we are assessing in a longitudinal manner.
Great. So you mentioned just now regarding the short chain fatty acids, right? So exactly what specific type of SCF is included in your supplement that you've developed, and how does it compare to the others that can be obtained from regular food sources?
So, for example, butyrate production was the one that has been shown to be increased. Now, when we are looking at short chain fatty acids, it's really, again, important to dive much deeper into optimizing them on a personal level to understand what it is that a person exactly needs. And what we know, what we can see from studies, again, coming back to the fibers, is that that we can increase the short chain fatty acid production in several ways. But again, when we are eating fibrous foods, our body needs more time and more energy to digest them. So this would be, let's say, in a way, by implementing fermented into our diets, it's kind of like having a shortcut and having a more optimal way to do it.
Great. Okay, so another question is asking, in addition to the brain, what other organ system do you believe is influenced by the gut microbiome? And are these interactions interconnected among various organ systems?
Definitely, it's not just about the brain. And the gut is, there is the saying that it's the second brain or the first brain, as whatever you like to call it. And as I mentioned again, it's all about the different levels of interactions and different organs interacting as well, different inputs. However, we focused on the gut-brain axis because when you're a startup, you always have one specific focus area that you need to explore first. If you go too wide, then again, what is it that you're exploring? But through the gut-brain axis, it's really about assessing the emotions and mental health, which we already know and science confirms are connected to the gut. So through looking at the outcomes on the level of emotions and with the help of AI, we are basically able to reverse engineer the processes and also utilize the data to predict over time, based on the longitudinal inputs, what are the patterns in one's behaviors, thought patterns, emotions, and so on, and how and why they should interact with which molecule. So it's a two-way system where we not only assess, but also provide interventions.
Right, thank you for that. The next question is asking if the gut microbiome of a mother directly influences the gut health of her child.
Yes. So that's when we look at in the field of gut microbiome, what we know is that, for example, children who are born vaginally and children who are born through a C-section have different microbiome fingerprints. Why? Because when you're born vaginally, basically you get the interaction also with the whole canal and also with the whole channel and also the feces of the mother and so on. Everything is kind of there when a person is leaving. Whereas when a person is born through a C-section, they are immediately, they miss this part of going out, right? They miss this part of the path that was supposed to be gone, and now there are things called vaginal swabs, etc., in order to actually provide the baby with the bacteria of the mother the moment they come to Earth. And that is still a field where there's a lot to be understood. There are even studies done previously from war times looking at longevity of people. And there was, it was a study that I was looking at recently. I don't exactly remember all the data, but basically the conclusion was that in war times, babies born from mothers who were pregnant during wintertime, when they had less exposure to different nutrients, they had worse longevity, so they died earlier, which was a very, very interesting study to take a look at. As I see we are a bit short on time, and I see one question that I would really love to expand a little bit on.
Okay, last question and a shorter answer.
Okay, so it's, what is your take on the symbiotic relationship of one's skin and gut microbiota, and have you considered influencing the skin microbiome too? Yes, and I don't think, I think that through influencing the gut, we are influencing the skin. So it's not two separate things. And we had multiple people come to us actually saying, you fixed my skin problems that I was never able to resolve throughout my lifetime.
Wonderful. I think you have such a wealth of knowledge. Thank you so much for sharing this. Nika, it was wonderful meeting you. Wonderful products, wonderful pipeline of randomized controlled trials and other studies. So well done. And thank you, Sabrina, for moderating. Thank you.
Thank you.
So after having learned so much about the gut, a couple of final announcements. We are organizing an exciting week of events around neuroscience and health longevity medicine. And due to the exciting enthusiasm of the field, the intensive course of the National University of Singapore Academy for Health Longevity is now fully subscribed. But there is absolutely good news for you. There are still seats available for the Unlock Health Longevity Supplements Conference, and that's at the 29th of February and at the 1st of March this year. Please also note that there is another course, the Health Longevity Talent Incubator, and that deadline is approaching at the 1st of February. So please have a look at longevityacademy.sg and in the chat box. On February the 1st, Professor Brian Kennedy is hosting Professor Hartmut Geiger. He is from the Ulm University of the Institute of Molecular Medicine. We are closing today, as always, with a short video. Ask me anything. Take care.
Hello. Hello.
Give me 5.
How old are you?
I'm 60, I think.
Do you sometimes do silly things?
I put milk in the washing machine.
Do you still go out on dates?
On dates? No, I go to buy dates, but...
Left the house without any trousers. And
What was you like when you was a teenager?
sometimes I was good, sometimes I wasn't. I had a lot of boyfriends.
Can you still kiss people when you have Alzheimer's?
Yes.
Did you dye your hair pink because you have dementia?
That's a very good question.
I love your hair. Do you know how babies are made? Who looks after you?
My wife, Vivian, the boss.
Do you ever get lonely?
Yes, I do. Very, very lonely. I'm on my own now, so I have to make the best of it.
I know that one day I'm going to wake up and not know who anyone is.
Do you have any life advice for me?
My advice would be,
Have you forgotten?
I have, yes.
Make sure you tell the people that you love them.
Treat every moment as though it's your last.
Stay away from boys.
It was nice talking to you.
I'm feeling like sunshine, like springtime, like something's in the water and I'm taking a deep dive. I'm feeling so weightless, like I'm gonna make it, and nothing in the universe universe can take this. I can see it clearly now. Nothing gonna bring me down.